So again, I am recording right now. As I speak, it's recording. The idea of today's lesson is we're stopping. We're not moving forward. We didn't do that great on last week's quiz, so we're going to review last week's section 3.1, both forms, function form and standard form, and understand both of the forms and when it's good to use them to graph. So let's begin with comparing function form versus standard form. What is function form? Getting the y by itself. So it is true that function form means get y by itself or solve for y. So in your notebooks right now, you should write down function form versus standard form. We're going to write a little bit about function form. We're going to compare it to standard form. And we're just going to review. So when we have y by itself, like here's an example of y by itself. Y equals negative 2/3 x plus 1. When y is by itself, it's really easy to graph using an input-output table, okay? I hope we all remember that a function is like a machine. You see, function form is getting y by itself, but once you have y by itself, it becomes like a machine that you could plug in values, pull out values. For example, if I had y equals, let's say, 2x minus 3, and let's say I plugged in the number, give me a number. 5. Okay, if I plug in the number 5 into here, what do I get out? I get out a 7, okay? What I would like you to do right now is turn to a partner and explain to them why when I plug in a 5, I get out a 7. Go for it. I want to pause it real quick. So, thank you for discussing. What if I plugged in a, let's say, negative 2? Plug in a negative 2, what do I get out?
Negative 1.
I get out a negative 7. So do me a favor, talk to a partner and find out why when I plug in a negative 2, I get out a negative 7. I'm going to pause it real quick. Thank you for discussing. Let's now plug in, let's say a positive 3. If I plug in a positive 3, what do I get out? Whoops. I get out a 3, right? Go ahead and talk to a partner and show or explain to them why when you plug in a 3, you get out a 3. Once again, thank you for discussing. Now, how about last one here? What if I plug in a, give me any number you want.
3.
We already plugged in a 7. Okay, if I plug in a green 7, what do I get out?
11.
I get out an 11.
7-11.
Okay, so you guys have been discussing. I hope we're all understanding that when I plug in a 5, where do I plug it into? Into the x. And 2 times 5 is 10, and 10 take away 3 is 7. So the 5 gets plugged into, that's why it's called an input. You plug it into, and it's also called an x value because you plug it into x. And when you do the math, 2 times 5 is 10, 10 take away 3 is 7. The output is 7. It comes out as a 7. It went in as a 5. It came out as a 7. Not only that, when you plug in the 5 in here and you do the math, what does it say? It says y equals 7. So it totally makes sense that this output is known as a y value as well. Okay? So input is the same thing as x values. The input, why is it called input? Because you put it into the function. And where do you put it in? You put it into the x values. That's why the 5 is also known as an x value. And the answer comes out as a 7. That answer is called an output, which is also known as the y value because it says y equals 7 when you do the math. Okay. So in reality, each one of these values, this 5, when I plugged it in and got out a 7, that's technically a coordinate, 5, 7. The negative 2, when I plugged it in, I got out a negative 7. When I plugged in a positive 3, I got out a positive 3 as well. And when I put in a positive 7, I got out an 11. So all of these are coordinates. And if you did plot these coordinates, it would graph a straight line. Okay? So I'm going to reiterate this one more time. The inputs, you put them into the x. So the 5 goes right here. 2 times 5 is 10. 10 minus 3 is 7. So the 5 goes into the x. It comes out as the answer 7. When you plug in a 7, you plug in the 7 right here. 2 times 7 is 14. 14 take away 3 is 11. So the input 7 gives us the output 11. Make sense now? Okay, great. And of course, if I graph them, it would be a perfectly straight line. So when an equation has a y by itself, that's called function form. And when it's in function form, that's when it's really easy to graph using inputs and outputs. Now, we're not going to draw a machine each time. What we're going to do is make an XY table. So we have an example right here that you guys jotted down in your notebooks. Y equals negative 2/3 x plus 1. We want to graph this thing. If we wanted to graph this thing, we would go to an input-output table, which is an XY table. And most of the time, I say use 0, 1, and 2, but in reality, you only need 2 points. So you only need to plug in 2 numbers, okay? The easiest number to always plug in is what? 0. Yeah, but specifically 0 is the best. Why? Because when you plug in 0 into x, it doesn't matter if you have a fraction or a decimal or a crazy number. Anything times 0 is what? 0. So this is your output. Whatever number is here, that's going to be your output. So when I plug in 0, what do I have? A positive 1. So 0, 1 is a coordinate, right? That's 1 point on the graph. All I need is 1 more point. Most of the time we use 0, 1, and 2. But if I did plug in a 1 right here, then I'd have a fraction, right? 2/3, negative 2/3 times 1 is a fraction. I don't want to deal with fractions, especially when I graph. I want nice numbers. So what would be an amazing number for x that when I plug it in, it would make the fraction disappear? 3, okay? So I want everybody to take this moment right now and understand that if you have a fraction in front of x, you want to plug in whatever the denominator is. So in this case, we're going to plug in a 3 right there, okay? And why do we want to plug in a 3? Because when I'm going to rewrite it here, it says y equals negative 2/3 times, if I plug in that 3 right there, and it still has a plus 1 at the end, plus 1, what happens with this 3 and that 3? It cancels out, so the fraction disappears. And what do I have left? I have a negative 2 plus 1, so it's going to say y equals negative 2 plus 1 is negative 1. So when I plug in a 3, I get out a negative 1. Does that make sense? Once again, this is so important. I'm going to pause right here. Not in the video, but I'm pausing right now in time. And I want you to understand that whatever fraction you have in front of x, you're going to use the denominator as the input. That way it cancels out. If this would have been a 5, I'd plug in a 5. That way it cancels out, no more fraction. If this was a 4, I'd plug in a 4. That way it cancels out, no more fraction. If this would have been like a 1/2, I'd plug in a 2. That way it cancels out, no more fraction. So obviously right here we had a 3. We plugged in a 3. It canceled out, no more fraction. And with these 2 points, you already could graph your line. Okay? That's what function form is all about. If you have an equation with y by itself, just go straight to an xy table, plug in 0, and you could plug in 1, 2, whatever numbers you want. But if you have a fraction, use a denominator. Okay? That way the fraction disappears. What is standard form? Because after all, form is just the way the information is organized. So yeah, function form is when y is by itself. What's standard form? How's that organized? Anybody remember from last week?
Isn't the x and y on the left side?
Yes, x and y are on the left side, and specifically here it is. The actual function form equation is capital AX plus capital BY equals capital C. Yes, it's true. X's and y's are on the left side of the equal sign. And then another fact is A, B, and C are just numbers, but we don't want fractions, and we don't want decimals. So if you ever did have a fraction, like let's say 1/2, you would multiply everything by 2. That way you don't have any more fractions. But standard form is simply having your x and your y on the left side of the equal sign. No fractions, no decimals, okay? Now, when you have an equation in standard form, I mean, you could use an XY table, but I don't recommend it. What's the best thing to do if they ask you to graph when it's in standard form? Anybody remember that from last week? And if not, that's okay. That's why we're reviewing. You want to find the x-intercept and the y-intercept, right? The x-intercept is where your line crosses the x-axis. The y-intercept is where your line crosses the y-axis. And we already talked about certain truths about x-intercepts and y-intercepts. Give me a second. So if we take a look at this graph and we look at the x-axis, this line crosses right there, this blue line crosses right there, this green line crosses right there, this yellow line crosses right there. What do we know about all of these x-intercept coordinates? They all have the y value of 0. Red 0, red 0, red 0, right? If you're talking about the y-intercept, any line that crosses the y-axis, that location is 0, 3. This location is 0, 1. This location is 0, negative 1. This one down here is 0, negative 3, right? So any y-intercept is going to have the x value of 0. Any x-intercept is going to have the y value of 0. So that's an important truth, and I showed it to you visually where that truth came from. But the reality is, how do you find the x and the y-intercepts? Well, to find your x-intercept, you set y equal to 0 and solve. To find your y-intercept, you set x equal to 0 and solve. And eventually, after doing this a couple of times, you'll be able to find the x and y intercepts without even doing any math. I'm talking about just covering up the x term, solving for y, and then covering up the y term and solving for x. So here's an example. Let's say 2x plus 3y equals 6. And because it's in standard form, you're not going to go for an input-output table, even though you could. But it's easier to just do the x-intercept and the y-intercept. So I'm going to write x int, y int, squiggly line in between. How do you find the x-intercept? You set y equal to 0 and solve. I'm going to put it in a little cloud because that's what you need to know in order for you to find the x-intercept. How do you find the y-intercept? You set x equal to 0 and solve. So I'm going to actually rewrite this equation, but instead of y, I'm going to put a 0. That's going to read 2x plus 3 times 0 equals 6. And of course, the 3 times 0 disappears, and you end up with a simple one-step equation that says 2x equals 6. What do I do to get rid of the 2? So that really says, let me rewrite it for you. 2x equals 6. That really says 2 times x equals 6. What do I do? Divide by 2, and I have my answer. The x is 3. Now, this is an x-intercept value. If you wanted the actual coordinate, bless you, if you wanted the actual coordinate, your x value is 3, and your y value was set equal to 0, so the y would be 0. That would be the actual location of where your line crosses the x-axis. It crosses at 3. The location is 3, 0. How about for the y-intercept? What do? You set x equal to 0 and solve. So if you did set x equal to 0, it wouldn't read 2x. It would read 2 times 0 plus 3y equals 6. And of course, the 2 times 0 cancels out, and you end up with 3y equals 6. And what's the answer there? 3y equals 6. What do you do to solve that? Divide by 3, and you get y equals 2. As an actual coordinate, it would be the x value of 0, because we set x equal to 0, and the y value of 2. So with these two coordinates, you could plot them on an xy plane, connect the dots, and you've graphed your line. So that's pretty much it for the entire lesson last week, right? If it's y by itself, that's function form. If your x's and y's are on the left side, that's standard form. When y is by itself, how do you graph it? It's really easy to go to an input-output table and plug in 0 and 1. Or if you have a fraction in front of x, 0 and whatever that number at the bottom is. In this case, 3. Okay. If it's in standard form, you go for the x and the y intercepts. And technically, all of this work is kind of unnecessary, because if you understand to find the x-intercept, you set y equal to 0. That's the equivalent of you just like getting your finger and covering up the y term. And it looks like a simple one-step equation, 2x equals 6. If it was 2x equals 6, divide by 2, x equals 3. You jump right to the answer. That's the location of where it would cross the x-axis. And then you would cover up the x term, because when you set x equal to 0, it would disappear. And you would have 3y equals 6, divide by 3, y equals 2. So you could get the x-intercept and the y-intercept technically without doing any work on paper. You could do it in your head. So it's very important to know these two different forms. What form is this one in? Standard form or function form?
Function.
Okay, so when it's function form, what's the easiest way to graph it?
Make a table.
Make a table, yes. Okay, guys, when you have y by itself, you need to make a table and plug in some easy numbers. Give me some easy numbers. What's the easiest number to plug in?
3 and 4.
Zero's the best. Because when you plug in 0, it doesn't matter if you're multiplying or whatever, that just disappears, and this is all you have left. So what is all that you have left when you plug in 0? A -2. And that is a coordinate, 0, -2, there it is. 0 on the x, stay in the middle, -2 on the y, put a green dot right there. Now we need another number. It could be any number you want. 1, okay. And when I plug in a 1 right there, what's 1 take away 2? -1. So that means 1 on the x, -1 on the y. From the origin, 1 on the x, -1 on the y. Put a dot right there. And you're done. There's your line. Oh, but it's so tiny. Okay, make it bigger. How? By using the pattern from one dot to the other. How do you get from here to here? You go up 1 over 1. Up 1 over 1, put a dot there. Up 1 over 1, put a dot there. And you could extend the line as far as you want. I mean, that's using the pattern. If you wanted to, you could have plugged in more numbers and pulled out more answers, but with those 2 dots, you could just extend it as far as you want, and your line goes in both directions. Sound good? Now, why did we go with an XY table? Because it's function form. Y is by itself. If this would have been in standard form, I would have gone with X and Y intercepts. Now, technically, I could, if I wanted to, change this to standard form. Let's actually zoom in on this, and I'm just going to change it to standard form. Check it out. I'm going to subtract X, and I'm going to rewrite this whole thing. It's going to say negative X plus Y equals negative 2. Does everybody understand what I just did right there? Just for funsies, I'm changing it to standard form. So how do I graph a standard form equation? I do an x-intercept and a y-intercept. I could show my work, or if I really wanted to, I could just understand that to find the x-intercept, we set y equal to 0. Now, if I did set y equal to 0, I could just cover it up because that means it would disappear. And there's a simple one-step equation here. Negative x equals negative 2. What would my answer be? If I had negative x equals negative 2, what's my answer going to be? X equals positive 2. There you go. And that's an x-intercept. Okay? Now, how do you find the y-intercept? Well, for the y-intercept, you set x equal to 0. Okay? So that's the equivalent of just covering up your x term. And that's, what does that say? It says y equals negative 2. So there's your answer, y equals negative 2. And technically, you now know where it crosses your x, where it crosses your y. It crosses your x-axis at positive 2. Doesn't it cross the x-axis at positive 2? Yes, it does. And it crosses your y-axis at negative 2. Here's your y-axis, there's negative 2. So with the x-intercept and the y-intercept, you could graph the same line. Okay? It just depends what form you have it in or what form you choose to write your equation in. Once again, if it's in function form where you have y by itself, go for a input-output table, plug in easy numbers, get out answers, those are your coordinates. If for some reason it's in standard form, do the x-intercept, y-intercept. How do you find the x-intercept? Set y equal to 0. How do you find the y-intercept? Set x equal to 0. And you'll know where it crosses. You put those 2 dots on the x-axis at 2 and on the y-axis at negative 2, and you'll have your same exact line. We had this paper from last week. I don't know if you want to look for it, but I'm going to go to the back side of this worksheet, and I want to pick one of these. I don't know, which one do you guys think would be good to do?
7, 11.
6? 6 is good, actually. I like 6. Remember, f of x, g of x, h of x, that's all the same thing as y. It's just the name of your machine. So that way, if I say, look at g of x, you'll know which one I'm talking about. But it's the same thing as having a y equals 1/4 x plus 2. So is that in function form? Is y by itself? Yes, it's in function form. Okay, so if it's in function form, how do I graph it? Input-output table. Okay. What numbers should I plug in? What's the easiest number to always plug in? 0. When you plug in 0 right in there, what's 1/4 times 0? 0. And then you have a 2 left over. So 2 is left over. There's your coordinate, 0, 2. And the next number you want to plug in would be 4. Yes, the denominator of the fraction that's in front of x. That way, when you plug in 4, the fraction cancels out. Let me show you. I'm going to rewrite it. Y equals 1/4 times, I'm plugging in a red 4 right there, plus 2. Of course, the 4 and the 4 cancel out. What do I really have? I really have a 1 plus 2. What's 1 plus 2? 3. So the location 4, 3 is my other dot. 4 on the x, 3 on the y. There it is. Again, 4 on the x, 1, 2, 3 on the y. There it is. Connect the dots and you're done. And honestly, that's like as hard as it gets because there was a fraction involved. But it's really not that bad. Okay? You plug in 0, you get that answer. So plug in 0, you get a 2. And then whatever number's down here, that's a number you're going to use as an input so it can cancel out. So if there's a 4, plug in a 4. If there's a 3, plug in a 3. That way it cancels out and you have a 1 plus 2, which is 3. So that's another example of a function form equation. We also had this paper from last week, which was standard form x and y intercepts. And when it's on the back side, we had more practice. I don't know if any of us did any of this, but as you can see, a lot of these are in standard form. And when it's in standard form, it's really easy to find the x and the y intercept. And I always recommend showing your work, even though you don't have to. How do you find the x-intercept? We set y equal to 0. And how do you find the y-intercept? You set x equal to 0. And you solve. So on the first one, when you set y equal to 0, you could, if you want to do it in your head, you could just cover up the y term. And that looks like a one-step equation. Negative 2x equals negative 6. You could even write that down. Negative 2x equals negative 6. And when you solve that, you divide by negative 2, divide by negative 2. What do you get as an answer? Positive 3, right? So yeah, x equals positive 3. This is your x-intercept. As an actual location, you would say that the x value is 3. And the y value, we said set equal to 0. So the y value is 0. And if you actually went to the graph, 3, 0 is right here. That's the x-intercept. I already knew it's going to cross the x-axis at negative 3. Now, that was because for the x-intercept, you set y equal to 0. How do you find the y-intercept? You set x equal to 0. So it's as easy as covering up the x term. And what kind of equation do you have left? You have a 3y equals negative 6. So you could write that down if you want. 3y equals negative 6. What do you do to get y by itself? Divide by 3, divide by 3. Y equals negative 2. Now, that tells you that it crosses the y-axis at negative 2. So it would be down here. I mean, if you wanted the actual coordinate location, well, the x value was set to 0, so the x value is 0, and the y value is negative 2. And when you go to 0, negative 2, 0, negative 2, you get to that dot. When you have those two dots, just connect your two dots, put some arrows on it. That's ugly, I apologize, but that's your graph. So it's really, really, really easy. When your y is by itself, make an input-output table, plug in 3 easy numbers, get out some answers. Or even 2 numbers. You don't have to go for 3. And when you have it in standard form, just think of x-intercept, y-intercept, and it's as easy as for the x-intercept, set y equal to 0, and that's the equation that you have. For the y-intercept, you set x equal to 0, and that's the equation that you have. And they're both one-step equations, really easy to solve. So we're going to stop right here. I hope that you guys go back and do the practice quizzes, or the practice quiz from last week, and go back and do last week's assignments, because we are retaking this quiz the day after tomorrow.